homework last night was worksheet number 12, 11 to 13. We're going to do 12 and 13 today, starting with number 12. Calculate the acceleration of the system in the diagram below. This question is largely like all of the other multi-force questions that we've done, with one thing that we have to do extra, and that is resolve this funny angle. We've got a force applied here of 15 newtons in this question. We don't know what applied that force. Maybe it was a tow truck. Maybe it was just some person pulling up on it. It doesn't really matter. There's a force of 15 newtons acting up the hill. Sometimes we might call that FA. Sometimes we might call that F1. Sometimes we might call it F37,112. Call it whatever you want. Okay, it's called FA in this diagram. We have two more forces acting as well. What other two forces act on this? What other two forces, fundamentally, that is, act on this? What do we draw down underneath this box here? Gravity. Yeah, gravity is going to act straight down. Gravity is going to act straight down. We don't know what its value is right now, but we could find that value pretty easily by just multiplying m times g. No tricks to that, no angles in that. Gravity is just straight down m times g. What other force do we have acting here? The normal force. And the normal force acts at 90 degrees to the surface right here. Exactly 90 degrees to that surface. Tell me when to stop drawing the normal force. Okay, I heard it from a couple people to stop there. That's where we would stop, right? Because this force right here, that is the sum of the normal force and the force of gravity, the force that joins the start to the finish, the resultant vector, the force that we're going to call F parallel, needs to be parallel to the hill. F parallel needs to be parallel to the hill, otherwise it's not going to slide down the hill. So, now we got to find F parallel. What's this angle right here? 30 degrees. It's always going to be the same as the angle of the hill. Yesterday we derived that, how geometrically it worked out to be 30 degrees, the same angle as the angle of the hill, or the incline of the hill. What side of the triangle is F parallel here? Is that opposite to this angle over here? Is it adjacent to this angle, or is it the hypotenuse? Yeah, it certainly isn't the hypotenuse, right? Because the hypotenuse is always the longest side. That's FG. It would be, what did you say, Miguel? Opposite side. So opposite, we have, or we're looking for opposite, hypotenuse we have, let's say sine 30 degrees is equal to opposite, F parallel, over the hypotenuse, which is the force of gravity, m times g. F parallel, therefore, equals, what, 5 times 9.81 times sine 30 degrees. That gives us F parallel of 24.525 newtons, I think it was. Same as it was in question number 11, right? Okay, there's F parallel. I like to kind of box that off because that's kind of separate. Okay, we've just resolved the vector. We've just gotten rid of that funny angle of 30 degrees. And now we're just going to go back and do whatever we do for all of these multi-force problems, whether it be the elevator problem, the pulley problem, just the straightforward multi-force problems, whatever it is, we say F net is equal to the sum of the forces. F parallel plus FA in this case. Why not? Why am I not adding in Fn and Fg? Why is it wrong to add in what I just added in? I've already included them, right? F parallel is Fn plus Fg. It's not like 3 plus 4 is equal to 7, adding them together, but it's adding them together vectorially, right? Fn plus Fg gives me F parallel. F parallel already takes care of that. So, not only is it not necessary to add those in there, it's wrong to add those in there. Now, the next step is to say, as it is in every multi-force problem, MA is equal to F parallel plus FA, and then we start subbing some numbers in here. My mass is 5, my acceleration is what I'm looking for here. Carissa, what would F parallel be here? What do you want to make F parallel here? Yes, let's make it negative here, right? If we just have that one force, we can make it negative or positive, whatever we want, really. But in this case, since we have that FA going up the hill, let's make it negative so that FA can be positive. If you did it the other way around, it would be okay. The force down the hill is positive, FA is negative. That would be okay, although it would be a little odd. I'm going to go with what you suggested, Carissa, and say F parallel is negative 24.525. And the applied force is 15 newtons. Does that make sense? All right, so 5 times A is going to be equal to, what is that, negative 9.525. And then A is going to be equal to, what's that going to be, like 1.9 something? Probably just 1.9 to 2 digits. 1.9 meters per second squared. Now, if there was a force of friction given to us, it would just add a third force in there. That wouldn't be a big deal, right? Which way would friction act if there was friction acting on this, kinetic friction? Up the hill or down the hill? Why would you say up the hill, Scott? Yeah, because it's going down the hill. Right? If it's going down the hill, friction is going to act to oppose that motion, so it's going to act up the hill. So if you're given that value, it's not really any harder. You just add another force. If you're given a coefficient of friction, if you're given a coefficient of friction, that would be a little ugly, right? Because the force of friction is mu times the normal force. What would the normal force be there? M times G? No. It wouldn't be mg because it doesn't cancel out with gravity, right? Anybody know how we might find the normal force to sub it into there? If you were asked that, you're not in this question, but yeah. Yeah, that's exactly what we do. We'd say cosine 30 degrees is equal to adjacent, the normal force, over the hypotenuse. And we just solve for Fn using mg cos theta. Does that make sense? So you get Fn using mg cos theta, and then you'd find the force of friction using mu times Fn. And then you have a number for the force of friction, and then you go over here and do exactly what we did over here, except that you'd add in a force of friction, if there was a force of friction in this question, which there's not. Good? Okay, let's take a look at the last one here. Number 13. It says calculate the last one that you were assigned, that is. Calculate the force of friction acting on the system in the diagram below. It's almost like we're going back to an easier question, right? Only one force acting, F parallel. Or is there another force? Yes, there's friction, right? Which way is friction going to act? Which way is friction going to act on this? In the absence of friction, which way will it move? Down the hill. F parallel will pull it down the hill, right? So if F parallel is pulling it down the hill, friction is going to act up the hill. We're trying to find that value of friction. We don't know what it is, right? What else do we got? We got gravity acting straight down. We got the normal force acting like this, perpendicular to the surface, 90 degrees, and just long enough to make this force that joins together the start of Fn and the end of Fg, the resultant vector, just long enough to make sure that that resultant vector is drawn parallel to the hill. That's why we call it F parallel. Now, I don't know how big FF is. We know it's going to be a positive value, right, opposite to the F parallel. We think of FF, force of friction, as being smaller than the other forces. Could it be bigger? Could FF be bigger than F parallel? Sure it could. If it's sliding down the hill and the force of friction is bigger, what's going to happen to this object as it slides down the hill? It's going to negatively accelerate, or actually would positively accelerate because it would slow down in the negative direction, right? Slow down as it goes down the hill. Does that make sense? Okay, let's get to F parallel here. This is 30 degrees. F parallel is what is that? F parallel is going to be opposite, adjacent, or hypotenuse. CJ? F parallel, which side of the triangle is that? Opposite, adjacent, or hypotenuse? Opposite, yes. That's opposite, that's hypotenuse. So we're going to say sine 30 degrees is equal to opposite over hypotenuse, force of gravity, or m times g. F parallel is 5 again, times 9.81 times sine 30, which is 24.525 newtons. Now let's label that. Just box that off because I've gotten rid of my funny angle here now, resolved that, turned it into something more manageable. And now let's just set it up like we do all the rest of them. These questions, the pulley problems, the elevator problems, the basic multi-force problems. F parallel plus FF. Starting to see how versatile maybe this whole multi-force problem. Like, we got like completely different looking problems, right? From elevators to this. But yet we fundamentally do the same thing. Remember I told you yesterday, there's two things in physics 20 that become used a lot in physics 30. One is vector analysis, and two is F net is equal to the sum of the forces. Like, we just did problems last week in physics 30 involving electric forces, when there were 3 electric forces acting on one object. What do you think we did with it? That. F net is equal to the sum of the forces, right? Except they were electric forces instead of like friction and F parallel. But same idea, right? Okay, ma is equal to F parallel plus FF. Mass is 5. Accelerate. Oh, look at this. We have the acceleration this time. It's 3 meters per second squared down the hill. So let's say 5 times 3 is equal to F parallel. Chris, we're going to make that negative again, right? We could make it positive, but if we did, then FF would be negative. I'm going to make down the hill negative. 24.525 plus FF, which is what we're looking for here. There's a small error somewhere here. Anybody tell me what it is? Yep. Yeah, we're going to make the 3 negative here. If we made the 24 negative down the hill, then 3 has to be negative as well because it's accelerating down the hill. 5 times 3 is 15, negative 15. And we're going to take that to the other side by adding. We're going to end up getting FF is positive 39.525 newtons, which rounds to, is that right? No, it's not, is it? It's 9.525? We're going to round that to 2 digits, so it becomes 9.5 newtons. So my F parallel was 24, friction was 9.5. It was smaller than F parallel, but it could have been bigger, right? It just wasn't. Actually, in this question, it couldn't have been bigger. Because if FF was bigger, it wouldn't have accelerated down the hill at 3, right? It would have decelerated down the hill at 3. Does that make sense? The downward force has to be bigger than the upward force, otherwise it doesn't accelerate down. You guys okay with that? How many people got that? Okay, not bad. Not bad for a first day, actually. What I'd like you to do now, after you've got that copied out, if you didn't get it. If you did get it, great. You have nothing to copy. If you didn't get it, make sure you have it copied. Once you've done that, I would like you to take a look at question number 14 and 15. Question number 14 and 15 on that worksheet. Let's have a look at 14, everyone. Since calculate the force of friction acting on the system in the diagram below. Where do we start with this? Where do we start with this? You've seen enough of these questions. You know where to start with this, right? Where do we start with this? Yeah, let's find F parallel. Hey, what is it? Like, what do I do with F parallel? Let's worry about that later on. Okay, let's just find F parallel right now. To find F parallel, we say we have a force of gravity acting down and a normal force acting not up, but perpendicular to the surface. It's going to be about that long, F parallel is. I know that because, sorry, that's Fn. Sorry, Fn is going to be that long. F parallel is drawn from start to finish, from the start of the Fn to the finish of Fg. It's the resultant vector, and it must be drawn parallel to the surface, right here. Now, force of friction is also acting. Which way is friction acting? I'm actually not sure right now. I don't know which way is friction acting. How come I don't know which way friction acts right now? Oh, yes, I do know which way friction acts. That's a lie. I do know. Which way does friction act? Pardon me? Yeah, it accelerates up the hill, right? Friction's going to act down the hill. So I'm going to draw this right here. Although, you know what? In the end, if you had it drawn it the other way, it doesn't really matter because you're solving for it, right? So your answer would have told you which way it was supposed to be. But yeah, if it's accelerating up the hill, then friction's going to act down the hill. Let's find the value of F parallel. This is 30 degrees. Let's say sine 30 degrees is equal to opposite, which is F parallel, over the hypotenuse, which is m times g. For the first time today, m is 10 kilograms times 9.81 times sine 30 degrees. That works out to be value of F parallel 49.05. Let's use the unrounded number there, 49.05, because it's not a final answer, right? Let's label that over here. And now what? Now what? We've done the hardest part. I wouldn't say the next part is easy, but it's easier than what we just did. What comes next? Good, thank you, Ella. F net is equal to the sum of the forces, F parallel plus FF plus FA, whatever's causing FA. Mass times acceleration is equal to F parallel plus FF plus FA. Mass is 10. A is, what was that, 1.5? Positive because it's up the hill, right? F parallel is negative 49.05 because it's down the hill. Plus FF, that's what we're looking for here, plus FA is positive 80 newtons because it's up the hill. So I'm going to say 10 times 1.5 is 15. Negative 49 plus 80 is 30.95. Let's take the 30.95 over by subtracting, and I get negative 15.95. Is that right? We want to round that to 2 digits. So my third digit is a 9. My second digit rounds up or down? Up. So it becomes what? 16 newtons, right? Negative 16 newtons. Which makes sense, right? That's consistent with what I predicted. I predicted that force of friction was down the hill, and I got negative, and so sure enough, friction is down the hill. This isn't so bad, is it? Like, we've done that how many times now? How many times? Yeah, a lot, exactly. Now, we haven't, this isn't so bad now. We've done this a few times, not nearly as many times as this, but we should be starting to get into the swing of this now, making it a little bit easier for us. Okay, continue on with number 15 if you haven't finished that already. All right, everyone, let's have a look at number 15 now. This one, listen, this one looks tricky, right? But it isn't really any worse than all the other ones. We just got to break it down. Break it down into manageable pieces. Okay, that's the strategy that we want to follow for everything that we do, is break it down into manageable pieces. Like, we started off this year by doing questions that said, like, here's the distance, here's the time, what's the average speed, right? Those were manageable pieces already. Now we've got questions that there's a lot to them, right? But if we break it down into those manageable pieces, like those questions that we had on the first day or things that are similar level of difficulty. We can do these, right? We just have to break them down into those manageable pieces. All right, so what do we got going on here in question number 15? First thing is, I'm going to say there's a force of gravity here. I'm going to call it, actually, I'm going to number these, object number 1 and object number 2. I'm going to say there's a force of gravity acting down here. I'm actually going to call it F2. I don't want to get it mixed up with the other force of gravity here, so I'm going to call it F2. You called it FG, that's okay. FG2, that's okay. Whatever you want to call it, whatever makes sense to you. For me, it's calling it F2. And the value for that is 5 times 9.81. Right? There is a force of gravity acting on the other guy as well, but that's not really relevant to this one, right? So let's worry about this one right now. 5 times 9.81 is 49.05 newtons. All right, good. What else we got here acting? Doesn't say anything about friction, so let's say there is no friction. Miguel, was that you that said that? F parallel, yeah. F parallel is going to act down the hill. Now, how big is F parallel? I don't know. We got to find that, right? F parallel isn't really a force on its own. Really, it's the sum of 2 other forces. What 2 other forces is it the sum of? Kinetic, what's one of them? Yeah, the force of gravity acting on object number 1, right? So I'm going to draw that downward here. The force of gravity acting down the hill, down towards the center of the Earth right there. You might call that F1, or I'm just going to call it FG because that's what we're used to calling that one. What's the other one? What's the other one that we have there? The normal force, yeah. And that's going to be drawn perpendicular to this one. And it's going to be drawn such that F parallel is perpendicular to that normal force, but parallel to the surface. In other words, it's got to be drawn the same as the original F parallel that I drew. Let's get that value of F parallel now. We've done that a bunch of times now, right? Like probably 5, 6 times. Let's say sine, this is 30 degrees, right? Always the same as the angle of the hill. Sine 30 degrees is equal to opposite F parallel over hypotenuse, which is the force of gravity. Be careful, it's that force of gravity, not this force of gravity. Although in this case, I guess it works out to be the same. Coincidence, though. M is 5 times 9.81 times sine 30 degrees. Okay, that works out to be 24.525 newtons. Let's label that. Actually, let's box that off because that's kind of what makes it different than the rest of the questions. And then let's label that 24.525 newtons. We're good? Now, with these inclined plane problems, I haven't done this next thing yet. What do you think, based on what we've done for other questions, what do you think I might want to do right now? Yep. Redraw it. Let's straighten it out. The reason I want to do that is because of that pulley, right? We have a force acting down right here. We want to make that negative because it's acting down. We have a force acting down the hill. We want to make that negative as well, right? But they oppose each other, so they can't both be negative. Let's straighten it out, and then it makes it a little bit easier to see why one of them should be positive. Here's object number 1. Here's object number 2. Object number 2 has the force of gravity acting on it. We're going to call it to the right. And object number 1 has F parallel acting on it. We're going to make that 24.525. Why am I not accounting for Fg and Fn on object number 1? We've answered this question a bunch of times already. Lucas, why am I not adding in Fn and Fg here? Yeah, I am adding them in. I've already done it, right? But now I'm going to say, same as I always do at this point, F net is equal to the sum of the forces, F parallel plus F2, or plus Fg2, or whatever it is that you called that second force of gravity. M times A is equal to the sum of the forces. What's the mass that I use here? 5, or 10? Use the total mass in these pulley problems, right? 10 times acceleration equals F parallel, negative 24.525, plus 49.05. I think that was set to be 2.4525, isn't it? We're going to round that to 2 digits, though. The third digit is a 5, so what does the 4 become? Do we round up or down? Yeah, the second digit rounds up. It becomes 2.5 meters per second squared. How many people got that? Good. Good, excellent. If you're having a little bit of trouble with that, then just practice it. Let me know. I can help you with it. If you got this, then you're set up nicely for our next question, which is what I call the mother of all questions. Let me draw it on the board here. I have a slideshow of it already, but if I just put up the slide of it already, then it reveals the entire question at once. And I don't want to do that. I want to reveal it over time. So here's how it starts. The mother of all questions. Well, no, I wouldn't say that, but what do you think? Maybe we should just make this like normally I don't do a midterm in Physics 20, but why don't we do a midterm and just call this the midterm? Because this is going to be pretty much everything from this unit. You want to do that? Actually, not just everything from this unit. It has some stuff from last unit as well. Let's just do that. One question, midterm. How about that? The mother of all questions. The mother of all midterms.
Well, our physics teacher did a pop midterm.
Yeah, other than that, it was great. Okay, here's our inclined plane. This doesn't look very hard so far. In fact, our angle of the inclined plane is 30 degrees, so clearly not very hard so far. Because sine 30 is 0.5, right? We have a 500 kilogram mass right here. Oh, that's doesn't look hard yet either. We got a pulley here. Oh, now it's starting to get them a little bit harder, but like the last question was like this, right? Here's a box down here. Except this box down here has a mass of 80 kilograms. So far, so good? That doesn't look too bad, does it? Okay, this is going to make it a little bit harder than anything you've done so far. There is a coefficient of static friction of 0.20. There is a coefficient of kinetic friction of 0.10. So you're going to have to figure out whether it moves or not to determine which type of friction we have, static or kinetic friction. And then once you figure out whether you have static or kinetic friction, find the value of friction, static or kinetic, whatever it ends up being. That makes it harder, right? But that makes it more like the second cousin of all questions. This is not anywhere close yet to the mother of all questions. Oh, wait, it's going to become the mother of all questions. We just haven't got there yet. This is like maybe the little sister of all questions. Now, this 80 kilogram box is actually an elevator where there's a person inside. The person has a mass of 50 kilograms, so it's a pretty light person. So the elevator itself is 80 kilograms, but the person inside has a mass of 50 kilograms. Okay, now it's like the auntie or uncle of all questions. So it's getting there. We're certainly getting closer to the mother of all questions. The person inside the elevator, oh, this is where it gets exciting. CJ, this is where you're going to just be like, oh, this is great. It's holding a ball that after 4 seconds, 4.0 seconds goes by, the person throws the ball at an angle of 30 degrees. And the question is, listen, here's the only question. Where does the ball land? How far away from where it was thrown? How far away from where the ball was thrown does it land? In other words, what's the horizontal displacement? The horizontal displacement of the ball. Hey, don't worry, it doesn't get any harder. Okay, don't worry, I'm not going to add anything else into this to make it trickier. So here's what's happening, guys. Just to reiterate here, we've got an elevator on a pulley, right, on an inclined plane with a person inside the elevator. The person has a ball in his or her hand. The person, after this thing is released, 4 seconds, let's say 4 seconds after release, after the system is released, we want to know, 4 seconds after the system is released, the ball is thrown. At an angle of 30 degrees, with a velocity, I missed that actually, that's important, with a velocity of 20 meters per second. So 20 meters per second at an angle of 30 degrees, we want to know how far the ball lands from the elevator. Now, clearly, this is a challenge question. If you're looking at this and thinking, I have no idea, you are selling yourself short. There is a good chance, I'm going to be honest with you, there is a good chance you will not get this question in its entirety. It's a hard question. But there is nobody that should be sitting out there thinking, I don't know where to start. You've got a lot of places to start. You know how to deal with friction. You know how to find the force of friction, right? Mu times the normal force. You can find the normal force on here, right? We've showed you how to find the normal force on here. You can find F parallel. You can do a projectile motion question. There's a lot of things that you can do here. You just have to break this crazy, difficult question, and it is a crazy, difficult question. You just need to break it down into manageable pieces and then put them all together. Okay? It's a challenge any way you look at it, but everybody can make a good start on this, and hopefully you can finish it off. I can live with it though if you can't finish it off. I can't accept you not starting. I can't accept you looking at this and saying, I got no idea where to start. Yes, you do. There's things that you can do. There's things that everybody can do. F parallel, all that stuff. Everybody can start it. That's a good question, actually. We're going to assume that this elevator starts on the ground. Assume that the elevator starts on the ground, and assume that the ball is thrown from like the bottom of the elevator. Okay, so you don't need to say like, oh, it's thrown 1.5 meters above the bottom of the elevator. Like the ball starts on the ground. Okay, does that make sense? Oh man, I'm making it easy for you now. Not quite, but the ball starts on the ground. It's thrown 4 seconds after the system is released, though.